Hello, this is Alex from cables.gl. I'd like to show you a really cool new operator that's just been released in the latest cables update called Pixel Difference. And we'll take a look really quick at what you can do with it, and hopefully that'll kind of intrigue you. And then we'll take a look at Pixel Difference operator parameters by itself, and I'll try to explain what it is generally doing. And then we'll quickly build a feedback loop, which is reliant on copy texture. And I think there is a tutorial on that. And I think it will be great if you go through that tutorial first, so you can easily follow along. And yeah. All right. So what's going on here? Right here, we have a pixel difference affecting a feedback loop that is then given to pixel displacement that then affects how this background image looks. So we have this kind of interesting polka dot waves going on. And I have some viz textures set up here that will show you this side of the feedback loop and then this special pixel difference effect. And what we have here is a black and white, very, very simple pattern going on. And then what pixel difference is doing is turning that into something that pixel displacement likes, which let's just quickly look. It likes a red-green input, right? So we turn this black and white image into a kind of funky green and red one, and then we get this interesting effect where it's pulling and pushing the pixels left and right and up and down, and that's pretty interesting. Okay, let's look at another example where here it's kind of a very messy application of the operator, but we have kind of an interesting idea going on here where I have a 3D object as my texture, and then again we're using pixel displacement with a kind of feedback loop to kind of affect the overall image, and maybe it could be an interesting transition or something like that. Let's look at something else. Here I have actually the same exact map from the beginning, the first example we just looked at, but I am kind of turning into something that more or less resembles a normal map, right? It's got blue in there as well. And then this is going into a phong material, and then I have some artsy things going on. So then we get this kind of 3D shape with displacement, but it also has this interesting kind of fluid effect on top of it. So that's one idea. And then we have kind of a similar idea where we have lights on a phong material that then again is getting a normal map. How does it look? Let's see. See, again, it's a black and white image. And then we have this red-green. And in this example, I actually used that and then a toNormal map operator to turn it into a normal map. And then we get this cool phong material that I have a mouse controlling the position of the light. And also when I click, I affect the texture. So it's pretty cool when you start applying some interactivity with these feedback loops, because then it doesn't just kind of look like a liquidy random wave animation. But yeah, see, so there is really interesting potential, I think, in doing kind of painting programs or applications, I mean, and kind of cheating a little bit using a phong material with a normal map to get kind of a glossy paint look without putting in too much effort into getting the gradients right. And that is a transition into this last example where I'm just painting some gradients and then displacing them. And we're getting this kind of cool animation with some feedback effects. And of course, this is all thanks to pixel difference. Okay, so let's take a look at pixel difference by itself. I have this really simple setup with a main loop and a sequence triggering one image compose and then another one with a draw image that is then getting an input from the first image compose. Then I got a viz texture, so we can take a look at what happens when we manipulate pixel difference. and then a full screen just to output it here in the renderer. So what I'm going to do is put down maybe a circle texture, right? So we have this white dot on a black background, and I'll make it a bit bigger. And yeah, we'll leave it. We won't matter. We won't worry about the aspect ratio for this thing. Okay, actually, I do want to change it. And the problem is this. So I'll make this 600 x 600. So now we should have a perfect circle. Oh, okay, I feel a lot better now. So what I did there was click on the renderer and then click on this resolution here. We can also just change the aspect by selecting a 1:1 and then quickly getting the result we desire. Anyway, so we have this perfect circle, and it's coming into this image compose, and then it's going into this full screen rectangle, right? Okay, so what I'm going to do is put down our pixel difference operator that we want to study. And you see that immediately something changed, and that is the default settings that are starting to affect this black and white image and giving us this kind of multicolored image that then we can pop into other interesting operators and use cases. So let's go through the parameter panel. We have a strength parameter, and that would affect the strength of the colors that are displayed, and then we can kind of move it to 0, and you see that the circle disappears. And if we move it into extremes, we get these really saturated colors. And then we have another parameter called step. And what step does is, since this operator, the main job, what it does is it compares the difference between pixels. So the step size is your range of comparison, right? So right now it's set to 1. So it's pretty much just looking at the surrounding pixels per pixel in the entire image. So this entire picture is being processed, and then it notices that, okay, now suddenly the pixels are no longer black, they're now white, and I'm reporting that there's a difference in the pixels. So the pixel difference starts to work, and then it uses these parameters under the method section to color specific to color your image in a specific way that you set in these drop downs. So the red channel, let's turn off this one as well. I'll go to 0 and then this one to 0. So now this method section doesn't have anything set for the green color or the blue color. And that's why we're getting this red only image. And then, so let's take a look. The red color of this image that we see on screen is giving us the horizontal difference in red. And this, I admit, took me a little bit to understand like what all these options are, but now I think I sort of more or less get it, and I can teach you. So what we have here is the different colors in the input image can then be assigned to this red channel. And right now, by default, it's the horizontal pixel difference for the red pixels. But to make it a little bit confusing, we have only a black and white image, right? So it's using the red from this black and white image because, you know, every color is, the white color is made out of every color. So it says, okay, well, the amount of red is changing here and whatever. So it works. But to be totally precise, we actually can use the luminance. So the black and white value changes. So if we set this to luminance, you see it didn't really change much because our input image is black and white. And if we set it to horizontal difference in red, it doesn't change because this white actually contains red. But anyway, I advise you, if you're working in black and white, just for simplicity's sake, set it to luminance. And let's do that. So the red channel, if you want, I can actually link maybe a Wikipedia article or something like that. But in general, if we look at normal maps, the red channel in normal maps will be the x axis. So it's left and right, right? And then, so we're looking at this um, horizontal change in this image and applying a red color. And it doesn't really, you can get creative, obviously, but if you're going to be doing something super precise with like normal maps, like in this example, I think it's a good idea to stay with the standards and put your red channel for the changes in the left right direction, and then set green to the changes in the y direction or up and down. So not a standard you're really required to follow, but I advise it just for the beginning. So the green, let's change it to the vertical luminance. So now we have this image, and we have this black and white circle turned into a red and green picture. Now, what can we do with this? I can maybe add a little bit of fall off. So now we see that the strength is being affected in a specific way in this output texture. You see it starts to fade out completely, and we'll turn off this overflow warning. As you see, if I have it on, I have this red red warning that actually is part of the texture, and I don't want that. So I'm going to turn off this warning and do whatever I want with this fade out. Okay, so why is this pixel difference kind of texture fading as we move the slider and fade out our circle to the edges of the screen or edges of this texture? Well, that's because our step size, which is like the comparison between the pixels, is 1. So it's a very small range. And as it looks over, there isn't much change going on, so it's kind of starting to fade out the difference that it's telling us in this input texture. And when you get into things like that, and you're like, well, actually, no, it is clearly changing to me from bright white to dark, black. We can use the strength to kind of readjust the way pixel difference reports this change. So definitely play around with these parameters, and remember that strength is kind of the multiplier of the colors for the difference in these pixels, and then the step size is kind of the range where the operator will look to report the change. Okay, so how about we do something cool already and get on with the program. Okay, so what I want to do is just show you a really basic, simple feedback loop with pixel difference kind of affecting this animation. And then after that, I guess I'll wrap it up and just include some links in the description of this video, and you can explore the other artsy things I showed here, which are actually quite simple, but yeah, they're a bit complex right now as we learn. Okay, so let's see what we need. I have a circle texture, and I maybe want to have some kind of waves coming out from it, right? I'll decrease the fade out a bit, and then what I'm gonna do is keep this section by itself, maybe move the trigger a bit over, and then here I'm gonna create my feedback. So I'm gonna type in image compose, hold down Shift, press Enter, keep my window open. Then I'm gonna need a draw image. Then I'm gonna need a copy texture. And by the way, if you're thinking, what is he doing? Definitely, again, check out the copy texture bite-sized tutorial. We cover this in there. And then another draw image. And then a pixel displacement. Pixel displacement is really cool, and it works so well with this operator. All right, so let's connect this all together. We have this draw image. I'm going to pop this out and add another viz texture here, this one. And then we'll get this little circle in here. Then I'm going to feed this circle into the copy texture and trigger it from another port from my sequence. I'll add another draw image at the bottom and then feed this copy texture over right there. And then we'll need the pixel displacement. And you see something happen already. But what we want to do is take this image, viz texture, this special pixel difference texture, and use that as the input for our pixel displacement. Then what I'm going to do, I'll just keep this default for now, but I think we might need to change this. This I'll leave alone. But here, the input is by default luminance, but we actually want red-green. So this red-green texture that we have from pixel difference will move and displace these pixels left and right and up and down, right? And then we can control the amount for the x-axis and the y-axis. What I'm going to do is also disconnect the full screen from here and pop it into this feedback loop. We have a black screen. Why? Because this copy texture draw image is set to amount 1, I believe. So there we go. We have something happening. Then pixel displacement is doing something. Now, why is this not working? Because the way you do these cool feedback loops is you need to do a pixel difference on this copy texture part as well. So if I just take the if I use a pixel difference for a static texture, obviously there's going to be no animation. So that is what's happening here. We're taking this static texture here and putting it into the draw image. What we need to do is disconnect this and plug this one into our pixel difference. And we get this really extreme explosion. And you see it is just too wild. And we'll get into controlling this a bit more, but the quickest way to adjust this is to first maybe lower the strength to something very small. And you see we're starting to get a more interesting effect. Then another thing you should keep in mind for controlling your feedback is this copy texture draw image amount. This we can increase to something a bit larger and see like how fine the numbers are starting to get, like 0.999, or here it's the strength is super low. So you're definitely going to be working with like really minute values to get really cool effects. But definitely try bigger values. But if you're gonna see something like this when you start, don't get discouraged. Just slowly start to adjust your values in the pixel difference operator, your copy texture loop, and then of course this pixel displacement. And I kind of like to go into really low values with this one too, like 0.002 or something like that. Let's just type it in. 0.002. Select this and copy it, and then just pop it in here. Now, not much is happening, but if we start to adjust our strength again, then we're starting to get their cool animation. And as the more we increase the kind of range of the comparison, the bigger our waves become. And yeah, we're slowly getting to kind of like getting the effect. There we go. So we're increasing this draw image for the copy texture, and we're now getting more pixels left over on our image, and it's starting to look pretty cool. Yeah, there we go. So that's pretty much the basics. And another thing I want to get into is, let me just double check everything. So the image compose that I use here has already been set up to have HDR, right? So if we turn this off and we keep it off, there's going to be situations where that's just not good enough. And we see some lines here, and it's, you can, it's of course great to not use HDR textures for this stuff because your project will run faster on weaker devices, or you're just going to get more performance out of it. But if you want to get really fine and your machine's really good, I advise going into HDR land, and then you're going to get like super nice effects. And yeah, I think that's pretty much it. This looks a little bit boring, so why don't we just fluff around here? Image compose, another draw image. I'll pop this into this one, and then pop this image compose into our full screen. And then here I can do something like, okay, like color map. That's the simplest and the quickest. Okay, so the color map will recolor this black and white image, or based on the luminance, will use another color palette on top of it. So we need an operator called color palettes, and this one's very simple, and it'll just connect into the color map and use this color palette as a way to recolor our image. And we have this smooth on here, and then we can select a nicer preset gradient, and then play around with our final image. Should I show you how to do normal maps? Let's see. Let's just look at how this example was set up. So I think here I did it a bit more efficiently than here, because here I'm taking this red-green thing where we just looked at for the pixel displacement, and then I'm using that image with a normal map. But actually, that's not really necessary to do, because what we have in the pixel difference itself is we do have a blue channel, and this thing can also be set up to be a difference, or a 0, or a midpoint, and then a 1 will kind of give you the standard normal map look, and then you can just plug it into a phong material. Okay, well, I rambled on long enough. Definitely check out this operator and look at the examples I will include in this video. Thank you. Bye.